Hello everyone, welcome back to part 2 of the Trig Mastery Check Solutions video. I'm starting at number 6, where you are asked to find an angle that is coterminal with negative 7 pi over 12. Well, I'm in the unit circle, and I'm thinking about where negative 7 pi over 12 would be. That would be just a little bit more than halfway around the circle. And so if that is negative 7 pi over 12, then does it make sense that this rotation has got to be the remaining part of the circle? So that's got to be 5 pi over 12. If you wanted to do this in degrees, you certainly could. And this is a good refresher. You could take negative 7 pi over 12 and multiply it by 180 over pi. The radians would cancel. And then you would get, let's see, 12 goes into 180 15 times. And so you would get an angle measure of negative 105 degrees. So negative 105 degrees, I believe, that's down here. And so why is this question so tricky for me? Well, let's see. Maybe my math is wrong. Okay, so a negative 105 would be there. And then to do the rest of that rotation, you would take 360 minus 105, and then the remainder of that, which would be 255 degrees, would be right here. Sorry, would be the rest of this part right here. So whether you have it in degrees or radians is completely up to you. And I'm still just pausing to look at this. If you can find the error that I've made, let me know, because I'm stuck on this. I'm going to move on to number 7. And we can discuss this one in class, or you can chat me individually. But this one, number 6, has continually given me a challenge. All right. Anyway, here we are moving on to number 7. Given that the sine of theta is 1 over 3, so I know that theta is some angle in standard position, and it's going to be 1 over 3 because sine of theta is always opposite over hypotenuse. So the side opposite is 1, the hypotenuse is 3. And I know that tangent of theta is going to be positive. That means that I have to be here in quadrant 1. What I need to do to find the value of secant, which is the reciprocal of cosine theta, is make sure that I have this side adjacent through the Pythagorean theorem. So I know that 1 squared plus a squared is going to equal 3 squared. I know that a squared is going to equal 8, and so a, if I take the square root of both of those, is going to be 2 square roots of 2. Now that I know that the side adjacent is 2 square roots of 2, I can say, okay, the secant is going to be, I can either do 1 over cosine, or if cosine theta is adjacent over hypotenuse, then secant theta is the hypotenuse over the adjacent. So I am going to take the hypotenuse, which is 3, and put it over 2 square roots of 2. Well, we can't have this answer as it sits now. We have to rationalize the denominator. So I'm going to multiply by the square root of 2 over square root of 2 and get 3 square roots of 2 over 2 square roots of 4. What the denominator simplifies to is 2 times 2, which ends up being 4. So I end up with 3 square roots of 2 over 4 for the secant of theta. Okay, and number 8, I'm going to find the amplitude, period, and phase shift of 2 cosine 3x minus 3 pi over 2. The amplitude is pretty easy. It's this number 2 that's right out here in front of cosine, which is 2. So the next part then is to find b and find the period, which is 2 pi over b. I'm going to find b by factoring out whatever I need to that's in front of x so that I can have x stand alone. And when I'm factoring, I am dividing. So when I divide by 3, that's the same thing as multiplying by 1/3. So what I've got here is a phase shift of pi over 2. You probably were able to see that if you factor a 3 out of 3 pi over 2, you're just left with pi over 2, but I wanted you to see that process. So the b value is 3. The period is going to be 2 pi over 3. And my phase shift, phase shift is going to be to the right pi over 2. Okay, last one in this video. For which two values of theta between 0 and 2 pi does cotangent equal? I don't know if that printed on your sheet, but it should say the square root of 2. Cotangent, remember, is going to be 1 over the tangent of theta. So what I'm asking you here is, where is 1 over a tangent of theta equal to the square root of 2? Well, hopefully you can see that that would mean that that I'm asking you where the tangent of theta is equal to 1 over the square root of 2, because if I take the reciprocals here on both sides, then what I'm asking for is where the tangent is equal to 1 over, tangent of theta is equal to 1 over the square root of 2. Now, you can type this into your calculator, and we can see together if this is going to work. So I'm going to do second tangent because I'm asked to find an angle. I'm going to make sure that my calculator is in degree mode. It is. And I'm going to find 1 over the square root of 2. We'll see what that gives us. Ah, perfect. And my answer makes sense. The tangent of 35.26 degrees is 1 over the square root of 2. Okay, and number 10, here's one of these questions that asks for the exact values. That means no calculator, because I'm going to want fractions or answers in terms of pi. Of the 6 trig functions of an angle, in this case it's going to be fractions because I don't give you a value of pi, with pi, of an angle that's in standard position, that means theta's at the origin, whose terminal side passes through this point. So -2, 5 is up here. The terminal side, meaning that's the end of the rotation, is right there at -2, 5. I'm translating that point in space into actual lengths of the legs of that triangle. So you guessed it, I need to find the hypotenuse with the Pythagorean theorem. This is a problem like the one that Diego showed us in class the other day. So I know that 4 plus 25 is going to equal c squared, and that c is going to be equal to the square root of 29. So here I go now with my sine, cosine, and tangent values. Remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The sine of theta then is going to be the opposite, which is 5 over the square root of 29. And if I rationalize this, then I get 5 square roots of 29 over 29. The cosine of theta is going to be the adjacent, which is -2 over the square root of 29. By rationalizing this, I end up with -2 square roots of 29 over 29. And tangent involves a little bit less work. It's going to be the opposite, which is 5 over the adjacent, which is -2. Now to find the cosecant and the secant and the cotangent, they're reciprocal trig functions, so I'm going to flip over my answer from to hypotenuse over opposite. So I'm going to be looking at the square root of 29 over 5. For secant, I'm going to be looking at the hypotenuse over the adjacent, so I'm going to be looking at square root of 29 over, or negative square root of 29 over 2. And for cotangent, I'm going to be looking at -2 over 5. All right, in the next video, I will finish these last few questions.